Okay, so today in 9.5b, we're going to look at something that's called complex fractions, and basically we'll be simplifying those down. Now, I gave you a few examples here of complex fractions. Here's what they are. A complex fraction is when you've got a little fraction inside of a bigger fraction. So here's a complex fraction. This one has some whole numbers. I guess this one did with the y, but it also has a little fraction within a big fraction. Now this one's got a lot of little fractions inside of a bigger fraction. So it doesn't matter if there's one or if there's tons. If you've got a little fraction inside of a bigger fraction, it's a complex fraction. And what we're going to look at today is sort of strategies to simplify those. Now by simplifying, I mean get it toned down so you don't have a complex fraction. You've just got one fraction going on. Now you're not going to probably, there might be a few exceptions, but probably will not be able to get it down to a whole number. You're still going to have a fraction, but not the double fraction thing going on. All right, so we're going to look at 4 or 5 of these, and here is the first one. So I have 1 over x plus 3 all over 5 over y plus 4. What I want to go through and do is I want to go through and look at my little fractions. So in my case, here are my little fractions. I want to look at my little fractions and decide on a common denominator for the little fractions. So in my case, I need to have the x and I need to have the y. So my common denominator would be xy. I'm going to take that common denominator, whatever it is, and I'm going to multiply by it top and bottom. Now I have to balance, so I have to multiply by a top and bottom or I haven't balanced my expression. Now here's the purpose of doing that. Then I can distribute it out. And what should happen as I simplify here is my fractions, my little fractions should go away. So let me go ahead and distribute and I'll show you what I mean. So here I'll have 1xy over x plus 3xy. Okay, in the bottom I'll have 5 times xy over y, and here I'll have 4xy. Now I want you to notice what's going to happen in each of these little fractions. What you'll see is that you will be able to cancel out the denominator. See how my x's cancel there? Here my y's cancel. If that does not happen, you need to go back and check your work because probably the mistake is in the common denominator that you used. So here I have y plus 3xy over 5x plus 4xy. Now you'll notice it's not the simplest answer in the world, but I don't have my double fraction. That's going to be my goal, is get rid of that double fraction. Then if I can simplify, okay. If I can reduce the fraction, that's great. If I can't, I'm done. Okay, so let's do a couple more. All right, now same as the last one, you'll notice I have a little fraction here and here. What I want to do is look at my denominators from the little fraction and decide what my common denominator would be. Now, since the denominators are the same, it's just going to be x minus 2. That's going to be my common denominator because it's the denominator from both of them. And then I'm going to distribute that out. So let me write out what I have. So when I distribute here, I'll have 3 times x minus 2 over x minus 2. You'll notice I'll get some canceling to happen there. Minus 5 times x minus 2. I kind of have to take my hit here to get the canceling to happen there. Here I'll have 2 times x minus 2 when I'm distributing down here. Minus 4x minus 2 over x minus 2. So both of my little fractions, you'll see I'll get canceling to happen. Now let's simplify this down and see what I end up with. Now let me just write out what I have first of all. We'll take it in a couple of steps. when you're on your own, you can try to combine steps a little bit if you want, not too much. So I'm going to distribute out my -5. And here I'll distribute out the 2. And then I'll combine anything I can combine. Now in the top, I can combine the 3 and the 10. In the bottom, I can combine the -4s. Now you see how we got a lot simpler. It's not completely simplified down, but it's a lot better than what we started with. Okay, so getting just a little bit bigger. You'll see we've got 4 fractions, 4 little fractions in our one big fraction. And what I want to do is pick a common denominator for all of these. Now I want us to focus on these x's for a second. Then we'll deal with the y's. I need to make sure, since this fraction has an x squared in it, I need to make sure that I have an x squared in my common denominator. Now that should take care of the other 2 that just have 1x, because I'll have 2 x's in my common denominator. I'll have x to the 2nd power, x times x, so I'll have 2 of them. So that should take care of my x's here. So if I have an x squared, I think that'll be fine. And I'll go ahead and stick it in the bottom. Okay, now in terms of the y's, pretty much the same thing. I've got y's in all of them, but I need to have y squared. I need to have 2 of them to take care of both this one and this one. And then I'm going to do the same thing. I'm going to distribute them out, top and bottom. Okay, so let me write out what we have. When I multiply the x squared, y squared here, I'll have 1 x squared, y squared over the denominator. Here I'll have 1 x squared, y squared, again, over the denominator. Okay, in the bottom, I'll have 1 x squared, y squared over the denominator. And here I'll have 1 x squared, y squared over the denominator. All right, now I've kind of created a mess here, so let's go through and simplify down. So this x will cancel with one of those. This y will cancel with one of those. So I'll have 1 xy left, just 1x, 1y. Okay, kind of the same thing here, except I don't have any x's, but both the y's will cancel. Okay, down here, the x's will cancel completely because I have x squared in both places. And this y will cancel with one of the 2, so I'll end up with 1y right there on the bottom. And then in my last place, the y squareds will both cancel. And this x will cancel with one of those. So all I have left is that 1x. All right, so this is what I've ended up with. Now, this doesn't happen very often, but I actually think I can simplify down a little bit more. So let's see what'll happen. I'm going to pull out an x here. So factor out an x. Remember, factoring never goes away, so get good at it. Now, the reason I did that is because now I can cancel out my like term, and all I have left is that 1x right there. All right, so this one's a little bit messy. If you need to rewind and kind of watch the steps again, do that because there are a lot of little details here. If you need to go back and watch it and pause and think about it, do that. There are a lot of steps. I want us to look at one more that's kind of big in terms of what the common denominator is. Now you'll notice, similar to the last one, 4 little fractions. What we want to do is go through, and I actually might need a bigger parentheses than that, go through and decide what my common denominator is going to be. Okay, now when I'm looking at these, I need to have a plain old x. I'm just going to write in the top, then I'll balance in the bottom. I need to have an x plus 1. Okay, I need to have an x minus 1. Okay, and then I need to have an x plus 1. Okay, I already got that. So this is my common denominator. Let me write it so I'm balancing top and bottom. And then I'm going to distribute out. All right, now I'm going to write small, but let me write out what we have. So when I distribute here, I'll have x minus 2 x plus 1, x minus 1, all over x. All right, so those will cancel. That's a lot I'm going to have to multiply out here in a second. Okay, here I'll have 2x, x plus 1, x minus 1, all over x plus 1. Okay, so these will cancel. All right, so that's nice. Down here, again, I'm going to distribute out. I'll have 3x, x plus 1, x minus 1, over its denominator. So the x minus 1s will cancel. And here I'll have 1x, x plus 1, x minus 1, over x plus 1. So these guys will cancel. All right, now looking at what I have here, I'm going to just write out what I have, then we'll go through and simplify this thing because it's going to be a little bit messy. So in the top, I'll have x minus 2, x plus 1, x minus 1. Okay, so that's from right here, minus 2x, x minus 1. Okay, that's not going to be so bad. I can distribute there. Okay, here I've got the 3x and the x plus 1. And here I've got the 1x, I can just write that as x, x minus 1. All right, so you'll notice, I'm going to screenshot this and take it to the next slide. You'll notice we have quite the big fraction here. We need to get that a little bit cleaned up before we have it as a final answer. It's just too messy. So I'm going to take this in a couple of steps. I'm going to start with this right here. So I'm going to go through and I'm going to FOIL that together. I think I'm just going to do it on the side here. So when I FOIL that together, I'll have x squared. Outside, inside are going to cancel. Okay, I like that. Minus 1. Okay, I think I can live with this because then I can FOIL those together. So I'll have first, outside, inside, last. Okay, this is messy, but I can write that down over here. Now I'm just going to put it in the order I like to usually put it in. So I'm going to put x to the third, then x squared, then x, then my plus 2. Okay, that's great. Now let me distribute out here. So I'll have minus 2x squared plus 2 negatives make a positive 2x. Okay, and I think I can combine some like terms there. But let me go ahead and finish in the bottom. I'll distribute here. So I'll have 3x squared plus 3x and distribute here. So minus x squared plus 2 negatives make a positive x. Okay, the top's going to be the messiest part, so let me do that first. So I'll have my x to the third. Now in terms of my x squareds, I've got 2 of them, so I'll combine those to get minus 4x squared. With my x's, I have negative 1, positive 2, so positive 1x, and then my plus 2. Now down in the bottom, I'm going to combine my x squareds. So I'll have 3 minus 1 is 2x squared. And combine my x's, so I'll get 4. All right, that one was big and messy, but here is my final answer. Now, I wanted us to do a really big and messy one. I'm quite sure I wouldn't give you one this complicated on a test. But I do want you to work at these pretty complicated ones. If you can get the complicated ones, you can get the ones that are simpler. Okay, so this is 9.5b, which is simplifying complex fractions.